This is a stocking density calculation spreadsheet. You'll be making one of these for yourself. The gray cells are the ones that you manipulate. Here you will enter your data. This is how many trees you have in each plot. And then you count the number of plots that you have and enter that number here. See if you mistakenly left it at 20, all of your numbers are reduced by half. If you left it at 5, everything's much too high. It's dividing everything by the number of plots. And then you have your desired density. That's off the stocking guide or density management diagram. That is the number of trees per acre. Now let's see what each one of these cells is doing. Spruce stocking, cell F2. If B2 is greater than 0, then enter a 1 in cell F2. Otherwise, enter a 0. There is greater than 0 trees in cell B2, therefore cell F2 is a 1. Cells G2 for fir stocking and H2 for white pine stocking are also 1s, and we have 4 balsam fir and 1 white pine within the plot. In this ranking, we're considering white pine to be the highest. That's why this cell is highlighted. The total stocking cell here is asking if all of these cells greater than 0, then 1, otherwise 0. There is a 1 within this range of cells, therefore total stocking is 1. The plot is stocked. Compared to plot 3, where we have no spruce, no fir, no pine, and no northern white cedar, the plot is not stocked. See that we have 8 plots that are stocked and 2 that are not, therefore a total of 8, and then that total of 8 divided by the number of plots makes 80% stocking, with that 80% formatted here. The same calculations are repeated below for each species, so we can see there are 5 plots that are stocked with spruce, 2 of which are remaining as our final trees because in these situations there is no other higher value tree outranking the spruce. But here we have a white pine which outranks spruce, therefore we don't leave it. So here we have an overall stocking of 5, or 50% here, which means that if we wanted this to be a 50% spruce stand, we could do it. We could not make it a 60% spruce stand with the current stocking. But here we can see the final stand after a brush saw treatment will be 20% spruce, 2 out of the 10, 30% fir, and then 30% white pine. That adds up to 8, which is our 80% stocking, and then we have 2 voids. Every one of these columns is summed here in the total for use in further calculations. Density of each species is calculated by the total number of trees recorded divided by the area sampled, and the area sampled is equal to the number of plots multiplied by the plot size. The plot size is calculated as the inverse of the desired density. Total density is the sum of all of these, and stocking here is the same as it was over there. So we have the total number of stocked plots divided by the number of plots sampled in total. Now let's enter some data for northern white cedar. 0, 0, 1, 0, 0, 0, 0, 0, 1, 0. So now let's say we've done some fill planting with our cedar and brought the stocking up to 100%. Now we're going to highlight these yellow so we can remember our decision here. And here's the other one, also yellow. That brings us to our final piece of data entry. We now have 2 plots stocked with cedar. We enter a 2. And now, as always, we check our data. We have 1, 2, 3 white pine, but we only have 1, 2 spruce and 1, 2, 3 fir. That was transposed during data entry, so we have 2 spruce, 3 fir. Now our brush saw treatment is going to remove 75 trees per acre white pine, 0 cedar, hope not, we just planted those, 375 spruce, and 1,050 balsam fir, for a total removal of 1,500 trees per acre, which is calculated as the sum of all of those, and a total retention of 750 trees per acre, the sum of those. This column has conditional formatting set, so if we highlight that cell, we can look under conditional formatting, manage rules, and see that if the cell value is equal to 0, it will be highlighted red. Let's see how to set that. So highlight cell rules, equal to, and then if I set that as 0 and light fill, I would hit OK, and it would do this. I'm going to hit cancel because I've already done it. Now these calculations down here, this plot size, 1/750th of an acre, is simply for reference. This will always match that. If you dive into the forest mensuration text, you'll see that the stocked quadrat method is built around a square plot. And a square, of course, we have the area of an acre divided by the number of trees per acre, so the amount of space taken up by each tree. The square root of that gives the length and width of your plot. It is much easier in the field to use a string or a stick to mark out a given radius, but a circular plot of the same area as a square plot is not going to give the same result. Studies have found that it's likely to underestimate the stocking. The solution to that is to use a radius equal to 1/2 the diagonal of the square. That is cell B1, the plot length and width, times the square root of 2 divided by 2. Make sure you get these parentheses right. To recap, your desired density is from the stocking guide or density management diagram. The number of plots is critical to all of these calculations. Data are entered here, visualized here, and then transcribed from here to here. Make sure you double check these values.